All right. Thank you for staying, first of all. I'm pleased to follow that previous talk. I didn't know that was going to come before me. But so my talk is titled Advice for Grads, a Scientific Approach. It's generally intended for the young students in the audience who will soon be leaving the comfortable and familiar confines of high school and stepping out into the unknown future, much as the pilgrim in the painting is doing. I hope that you find some of these things enlightening, empowering, and educational. Of course, this can apply to anyone in the audience as well. So let's begin. Piece of advice that I'd like to offer grads, number one. Learn to empathize. That is, learn to understand the point of view of others. In 1927, a Belgian astronomer and Roman Catholic priest by the name of Georges Lemaitre proposed that the universe is expanding. 2 years later, an American astronomer named Edwin Hubble confirmed that galaxies are indeed moving away from us, and the speed of recession is directly proportional to their distance. That is, galaxies that are twice as far away are moving away from us at twice the speed, 3 times away, moving away at 3 times the speed, and so on. So there is a direct proportionality. It looks something like this, and this is kind of crude, but it's the best I could do with PowerPoint. So here's the observer in the middle, and we look out at all the galaxies around us, and they're all receding away. Hubble's observations were made from our place in the Milky Way, and from this point of view, it appears that we are the center of the universe. Now, if we trace that expansion backward in time, all of the matter in the known universe arrives at the same point and at the same time in the distant past. This is popularly called the Big Bang Theory, although Lemaitre preferred to call it the cosmic egg exploding at the moment of creation. Again, by this observation, it looks like our place in space is where it all began. However, let's just switch the position of the Earth with one of those other galaxies and see the same expansion that we saw before, the same proportional expansion. So switch the Earth and this galaxy. Now keep your eye on the Earth, it's going to move, but imagine measuring the recessional speed of all the other galaxies from your fixed position on the Earth, and it looks exactly the same. The observer still perceives themselves to be at the center. So the point is, any observer from any vantage point in a universe where space is expanding will think that they are at the center. Therefore, the perception of being at the center is an illusion. A similar illusion occurs locally when we observe the rising of the sun and the moon, the stars and the planets in the east and setting in the west. Who could fault the collective of humanity for believing for over 2,000 years that Earth was fixed and in the center of the universe? It's a comforting illusion. We can all admit that we know someone, or maybe even have been someone, or are someone, who thinks that the universe revolves around them. So the point is, and the advice is, other people may look different than you, they may dress different than you, they may think different than you, they may feel differently than you do, they may have different political ideologies, they may express their ideas of faith differently than you do. Opposing viewpoints are necessary, but they are not necessarily right or wrong. And sometimes neither is actually true. The only faulty viewpoint is one that considers itself the center and lacks the ability to see from another perspective. By its lack of empathy, it can do harm to others. So I encourage you, grads, be your own Georges Lemaitre, be your own Edwin Hubble. If you care enough to look, you can discover the expanding world around you and realize that no one is at the center, because the physical truth is there is no center. It's all relative. Advice number 2, see the big picture. This is Mount Everest. Its peak, the highest point on Earth, stands at about 5.5 miles above sea level and growing 0.4 of an inch per year. Inversely, the lowest point below sea level is a trench in the Pacific Ocean. It's about 7 miles below the sea level. So why does our planet have these high and low places? Why isn't it smooth like, say, a billiard ball? Well, in a planetary scale game of seismic bumper cars, enormous tectonic plates grind and scrape smash and separate from each other. In slow motion collisions, happening right now below our very feet, over expansive tracts of geologic time, prodigious amounts of potential energy are being stored at the boundaries between these plates over centuries and millennia, and that energy is then abruptly and violently released in very short periods of time. And this is the cause of all the world's earthquakes, volcanoes, and mountains, including Mount Everest. So this little video shows around 50 million years ago, the Indian plate began drifting to the north relentlessly and collides with the Asian plate. In the ensuing collision, continental land masses are thrust upward because of their same density. So neither subducts under the other, they both go up. And so a mountain chain is born. The collision is still happening today as we stand here, or sit here. And so the world's tallest mountain chain is growing right now, 0.4 of an inch per year. Earth's tallest mountain is getting taller. This is a gorgeous panorama taken from the International Space Station. This is about from a distance of 200 miles from the Earth. The Himalayan mountain chain doesn't seem quite as big from this perspective. Mount Everest is there just disappearing off to the right-hand side and reappearing now. There's Everest in the middle. Doesn't quite seem as big from this vantage point. So what if we go further back? Is the Earth actually as smooth as a billiard ball? Does it depend on our perspective? Well, the ratio of Mount Everest's height to the diameter of Earth is 5.5 miles over 8,000 miles. That's a ratio of 1 over 1455. In other words, you could stack 1,455 Mount Everests from the South Pole to the North Pole, and the tower would be equal to the diameter of Earth. Okay. So back to that billiard ball. If Earth were this size, how big would Mount Everest be? Well, if we apply the same ratio, the billiard ball is 2.3 inches in diameter. Apply the same ratio, and Mount Everest on this billiard ball would be 1.6 thousandths of an inch tall. It's a small number, right? It's probably too small even for us to imagine. So let's use something that we're all familiar with on that scale. How about the microscopic mountain chains on the tips of your fingers? Your fingerprints. So this is a sort of microscopic view of your fingerprints. It looks a lot like a mountain chain. Depends on your perspective, of course. This is from a study, a detailed 3D study of fingerprinting. Light was bounced off of fingerprints to determine factors about them. And the fingerprint ridges were determined to be about 5 thousandths of an inch deep in the average human fingerprint, 5 thousandths of an inch deep. So that means your fingerprints are 3 times taller than Mount Everest would be if Earth were the size of a billiard ball. So imagine standing at the base of the Colossus, Mount Everest, looking up, 5.5 miles up into the atmosphere it stands. Now, take the billiard ball, get in a rocket, if you have that capability, or just use your imagination. Zoom away from the Earth, just over about 100,000 miles. That's less than half the distance to the moon. Okay. Turn around from this distance and look at your home planet with your billiard ball in your hand. Hold the billiard ball up at arm's length, and it will just cover the Earth from 100,000 miles away. If you could reach your thumb out and run your thumb over the top of the Earth, it would feel quite smooth, like a billiard ball. So, the advice. In your life, it's a good idea to take a step back to see the big picture once in a while. It'll help you see where you've been, help you see where you are, and of course, it'll help you see where you're going, most importantly. Obviously, this is easier said than done. It requires much persistence. After all, humans only became a spacefaring species after much hardship and sacrifice. It took incredible motivation to physically leave the planet to get a view from this vantage point. So try to keep your obstacles in perspective. The person next to you, sitting in the chair, may be quietly dealing with climbing a metaphorical Mount Everest on a daily basis while you fret over anthills in your way. What's a big deal to you may not be such a big deal to your neighbor. So in your journeys, try to remember the big picture. Number 3, never give up. So you have an obstacle between you and where you want to be, generically speaking. Geologically speaking, wind and water, both fluids, reconstruct the solid landscape given sufficient time. Assisted by gravity, the Colorado River has carved away the Grand Canyon over millions of years of persistent flow. You don't have millions of years, you say. Well, flash floods. These don't require much time at all. Just the power in their persistence is enough to drastically change the physical landscape, as seen here in these canyons in Utah, where regular flash flooding is a common occurrence. It carves undulating waves into the solid rock. Your inspiration may come suddenly. It may come unexpectedly, as long as you're open to it. In a flash, you go from not knowing something to knowing something, and then you're off and on to the next thing. Beyond high school, you will face adversity. You will face resistance, but if you want to change the landscape of your life, you have to be the persistent force influencing transformation in your own life. Happiness, success, all these things that all of us would strive for, they don't simply fall out of the sky as if by magic into our laps. You must be an active participant in your own future, shaping your own future. With a lot of persistence and a little luck, you can make it what you want. Speaking of luck, number 4, appreciate how lucky you are. This is your family. As you on the bottom, your parents on top. This goes back 4 generations to your great-great-grandparents. You had 16 of them, 8 great-grandparents, 4 grandparents, 2 parents, and you. I'm lucky enough to have mine in the audience. This is 30 people who made random and specific decisions in their lives that led you to be here. This is just 4 generations, going back perhaps 100 years. Okay. Let's go back a little further. This is 7 generations of unique ancestors, and I stress the word unique because it can happen in nature that a pair of parents shares a common ancestor somewhere down the line, but that's a different discussion for a different talk. This is 254 of your ancestors, going back just 7 generations prior to you. Each pair responsible for passing their mixed genetic material down to you. So if you really want to be amazed, go back 20 generations. That's just about 500 years ago. In the year 1514, you, as an individual, had over 1 million people on the surface of this earth that made decisions that led them to be together, that led to the next generation, that eventually and ultimately led to you being here. Think about it. If one of those people did one thing a little bit differently, you'd not be here. If they made a left instead of a right one day. Appreciate the luck of that, because there's a lot of luck there. Here, a different type of cosmic egg. On this level, what's even more amazing is that each sperm and each egg has one of 8 million possible combinations of 23 chromosomes. Okay. Now, when they combine, this leads to over 70 trillion possible combinations of genetic material that can lead to an offspring. 70 trillion possible combinations with unique traits. So had any other sperm met any other egg, you'd not be here exactly as you are. You'd be quite different, in fact. It's humbling, I think, to consider these odds and to realize that your unique genetic makeup is literally one of tens of trillions of possible outcomes that could have been from your parents, could have been produced. And yet, there you are, sitting in your chair. Truly, 1 in 70 trillion. And you were the one given the chance to be here. So, regardless of your situation, appreciate that you're even here at all. That you were the one given the opportunity, the implausible opportunity to be here, to experience life in all its mystery, its beauty, its sadness, and its joy. Richard Dawkins said it best, I think. He said, "In the teeth of these stupefying odds, it is you and I, in our ordinariness, that won the lottery of birth against all odds." So, carpe diem, seize the day. You were born. It's the only life you'll have. Do something extraordinary with it. Number 5, be aware and be wary. As an educator, I have to speak to this. I hear it often, and I cringe every time I hear it, and I hear it too many times to count. I'm not good at science, they say. Science isn't my thing, they say, as they stand there with an electronic handheld device in their hand that is simultaneously a phone, a radio, a jukebox, a computer, a GPS locator, a television, a calculator, a camera, and a gaming console. Science isn't my thing. This is optics. This is electromagnetics. Right? As an infant, you were born good at science. Every single intelligent living being is born good at science. No one is born bad at science. I hear kids say it too much. You tested the world around you by observations when you were born. For example, the parents come running when I cry, and they give me what I want. The juice spreads from the cup when it spills. It never goes back in. The tower of blocks falls over and down to the ground, never up to the ceiling. That thing over there is hot. Don't touch it again. It hurt. Right? The mom doesn't like it when I pull on the dangly, shiny things from her ears. From these observations and interactions, you slowly began figuring out the natural world around you. And lucky for you, you had others in your life to share with you what they had already learned. So you did not have to start from scratch. This is science. This is the process, and this is how we advance. Your life is absolutely surrounded by these things, the products of this method. Modern civilization is built on that, I would argue. Science is not a body of knowledge or a book of facts or white lab coats and goggles. When you fail, it's an opportunity to learn something that you did not know before. When the result of the test is exactly what you expected, then you already knew. No, you didn't have to learn anything. So, embrace your mistakes. Embrace them as a chance to learn something you didn't know before. I encourage you to use this method every day. It'll make you more aware of the world and more wary of it, too. And finally, I'll leave you with this one. Express your creativity. We are all creative from the time we're born. Some of us stop being creative, as we heard in some of our previous talks. Express your creativity. Write, draw, imagine, paint, dance, and sing, even if you're not that good at it, for example. All right, this is, I've got to time this here, so I never really appreciated the power of PowerPoint until doing this. Whenever life gets you down, Mrs. Brown, and things seem hard or tough, and people act stupid, obnoxious or daft, and you feel that you've had quite enough. Just remember that you're standing on a planet that's evolving and revolving at 800 miles an hour. It's orbiting at 19 miles a second, so it's reckoned a sun that is the source of all our power. Now the sun, you and me, and all the stars that we can see are moving at 6 million miles a day in an outer spiral of 200,000 miles an hour of the galaxy we call the Milky Way. The galaxy itself contains 300 billion stars. It's 100,000 light years side to side. It bulges in the middle, 16,000 light years thick, but out by us it's just 3,000 light years wide. We're 30,000 light years from galactic central point. We go round every 200 million years. And our galaxy, it's only one of millions and billions in this amazing and expanding universe. The universe itself keeps on expanding and expanding in all of the directions it can whiz. As fast as it can go, and that's the speed of light, you know. 12 million miles a minute, and that's the fastest speed there is. So gaze up at the sky and start asking why you're even here on this ball. For though life is fraught, the odds are very short. You're lucky to be here at all. Though this life is fraught, the odds are very short. You're lucky to be here at all.